And I hope you all understood the rate of change, Anna.
Yes, sir.
You all did. So today we are going to do small changes. So when there's a change in a certain quantity, that's basically what we are going to talk about. And it is going to be represented by partial derivative of x. This one is not dx, so this one is partial derivative. So the symbol is if you do advanced engineering, you get to understand when you talk of partial derivative. That's it. It's like d, but that one is a little bit curly. So supposing you know y is equal to f of x, y is equal to the function of x. That you already know under differentiation. I'm recording, I guess. Yeah, under differentiation. Now, supposing s changes by a small quantity, dx, there will also be a corresponding change in y. Now, when you have y is equal to f of x, and there's a small change in x, then that means it's going to affect y, right? Or because y is equal to f of x. So when there's a slight change in x, there's also it's going to affect y, right? So there's going to be a change in y, which will also be denoted by dy. So the change in y, so change. The Basa people are holding and listening. So the change in y. So change in y. There will be a corresponding change in y, which will also be giving us the partial derivative of y. So that's why we call it partial derivative. That is different from the differential partial derivative. When you do advanced differentiation, when you do the ODs and the rest, you do all these things. We did them at university. So that will also be denoted by the y. So we wish to find an approximate value for the y. So we would want to find an approximate value for the y. So now we can say that, okay, changing, this one is also change. So changing the y raised partial derivative of y, we can still call it the y. All over dx is equivalent. When we say equivalent, it's equal to or equivalent to the normal dy we know. The differential of y all over dx. All over dx. Now, looking at this formula, if you want to find for the partial derivative of the y, if you want to find the partial derivative of the y, then that means what you are going to do is the smaller change, which is the partial derivative. We are talking about the smaller change in quantity. Dy will be equal to this one times this, right? So it's going to be equal to, this is dy all over dx times a partial derivative. So this is Kelly. So something like this. It's Kelly like Maureen. So oh, there's x. Sorry. So that's what we are going to get. So we are saying that supposing, or let y is equal to f of x. Now supposing x changes by a small quantity. So now we believe that x has changed by a small quantity. You get it? By a small quantity. Then that means if there's a slight change in x, then that is going to affect y too. There will also be a slight change in y because y is equal to f of x. Now as a result, we would want to find the approximate value for the smaller change in y, because already we've been given that there's a small change in x. Now we want to find its corresponding to y, and the formula is given by partial derivative of y is equal to dy all over dx by the partial derivative of x. I hope I've made myself clear. So this is going to be our formula or formulae, just as the Basa fans will say it, formulae. So that is it. So basically, this is what I'm going to use in the calculations. If you have enough time today, I'm going to do maximum and minimum, hopefully. So that is it. So let's do some questions. So there's the formula I'm going to use. Okay. Now, question number 1. Find the approximate change. Find the approximate approximate change. What am I even typing? Approximate change. One approximate change in the area of a circle. In the area of a circle. In French we say circle. C-E-R-C-L-E. So a circle, if the radius is increased, from 3 to 3.01. So the change, you can now tell me that there's going to be a change, which is that will be the difference between the 3.01 and the 3. I hope I made myself clear. So find the approximate change in the area of a circle. In the area of a circle. If the radius is increased from 3 to 0.1. So there's the initial radius and it has been increased. So the increment would have to do with the slight change in, what do you call it? The increment brings a change. Are we there? Because I was maybe 12 feet tall or maybe 4 feet tall, and now they are saying that I've been increased to maybe 5 feet, and that means the increment brought about a change. So as a result, if I want to get the exact change or the exact increment, then I'll have to subtract the previous from the latter, right? So that is basically what it's going to be. So now let's solve it. After getting this, they are just going to use our normal formula. So our normal formula, what are we going to do? This is a continuation of what we did last week. So using our normal formula, what we are going to do is we are first going to quote the area of the circle. What's the area of the circle? Area of a circle is what?
Pi r squared.
So area of a circle is equal to pi r squared. Now, here we are talking about change in radius here. So that means you are going to differentiate area with respect to radius. Have I made myself clear? So this will be the area all over the radius. So we are going to get, when I differentiate it, what am I going to get? 2 pi r. I hope I'm correct. 2 pi r.
Yes, sir.
So now they are saying that when the radius is free, then I can substitute 3 here, right? To get the radius of what they call the initial radius of the what do you call it, the circle. So I'm going to get this, the radius they are saying is 3. So this will give me 6 pi, right?
Yes, sir.
This will give me my 6 pi. So now when r is free, I'm going to get dA all over dr to be 6 pi. Now they are saying that there's a change in radius, and the change in radius, which is the partial derivative, the small change in radius, will be equal to, initially was free. Initially it was free, and now they said it was increased. So we want to now find the change. So the change will be free. Will be change we have 3.01 minus 3. What are you getting? That will be the smaller change in r. Change in radius. What are we getting?
0.01.
0.01. So they are getting 0.01. So now we are looking for the area. And the question says that find the approximate change in area. So we are looking for the area. Have we gotten it? So the area is this one, this one, small a. So comparing it to this one, comparing it to this one, the y all over the x is this one, the a all over the r. So now we are looking for the smaller change in what? Area. There's it. So this one be equal to the area all over the r times a smaller change in r, which we have to be 0.01. So uh, so that'll be r. So a smaller change in area will be equal to, but we know the area all over the r, or the a all over the r, or the ADR is 6 pi, right?
Yes, sir.
6 pi by or times our smaller change in r, which is 0.01, right? 0.01. What are you getting? Those were the calculators. So a smaller change in r, a.
Yeah, please, 1.88 times 10 raised to the power
Please,
negative 1.
I'm coming. So we are going to get the Basa fan. So we are going to get 0.06 pi. You can then you can continue to write, or you can leave your answer in this in pi, or whether so you can continue with what you said by converting a pi to the 3.1 something and multiplying by this thing, whichever way should be correct. But I always advise that you first start by writing this answer, then when you finish you further write this thing. There are some of the invigilators, the questions or some of the markers or the examiners. For instance, if HOD is a math teacher and he's the one marking, he's marking according to the marking scheme. Now he may decide to say, teacher Kojo, please, I'm tired, help me mark. You got what I'm trying to say, looking at the marking scheme. And because I may not, I'll be in a hurry to finish marking, I may not even find time to go and check all these things. There's some instance the student might just wouldn't write this. You just right away write the full answer. And if the examiner is marking and he sees that one, he might think the person is wrong, but he just because the marking scheme just wrote this one. I hope I've made myself clear. So you can just write this, then later you follow up with this one. Are we there?
Yes, sir.
Good girl, good girl, good girl. Okay, so let's do this one. Find an approximate value for the radius of a sphere. Find an approximate value for the radius of a sphere. Find an approximate value for the radius of a sphere. Find an approximate value for the radius of a sphere. Find an approximate value for the radius of a sphere. If its volume is increased by 25 cm cube, if its volume is increased by 25 cm cube, if its volume is increased by 25 cm cube, when the radius is increased by 0.04 cm, when the radius is increased by 0.04 cm, take pi to be 3.142. Find an approximate value for the radius of a sphere if its volume is increased by 25 cm when the radius is increased by 0.04 cm. So now the change in volume you are given to be 25 cm cube. So continue. So yeah, you are not going to do any subtraction. You've already been given the change in volume to 25 cm cube. So you can just do the work. I'm waiting for my answer. But I guess I'm Jollofa, eat pepper. This one said it's increased by, so that's the difference. The other one said increase from this to, so you do subtraction, but this one is increased by this. So the difference you've already been given to 25 cm cube. So the rest is your work. What are you getting? What are you getting? Remind me small. Maureen. 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 Asha.
Yeah.
What do you get? Hey, you guys remind me small.
I'm not getting it too.
So that's why I'm calling you guys. Oh, say you are not getting it, so that you do it. So let's erase it then. So I'm going to do it. Small changes. After differentiation, I do integration. So let's take note. So someone should read the question. What was the question? The question states that find the approximate value for the radius of a sphere. So we are finding for an approximate value for the radius of a sphere. So we are looking for the radius of a sphere. If its volume is 25 cm, if its volume is increased by 25 cm, so change in volume. Sorry. So change in volume is 25 cm cube. Now the question also states that change in something, change in radius or the radius is also increased by, so change in radius is also 0.04. Then we should take, they are all in cm. Take pi to be blah blah blah. So that's what we have. So the first thing we are going to do is we are first going to quote our the volume of a sphere. So the volume of a sphere is what? Volume of a sphere. Someone should tell me. The volume of a sphere is 4/3 pi r cube. That's the volume of a sphere. That's the volume of a sphere. So the volume of a sphere is 4/3 pi r cube. So we are going to differentiate V with respect to r. Just as formula this thing. So the V all over the r. The r is equal to, this one will give us 4 pi r squared. Now, but according to our this, the question says we should find for the approximate value of radius for the radius. So we are looking for the radius, approximate value for the radius. So there's it. So we are looking for r. There's the approximate value for the radius. We are looking for r. This one is the change in radius, not r, not the radius itself. There's a change in radius. So we are still going to use our normal formula. The normal formula is small v, the v should be equal to the v all over the r times small the r, which is a smaller change in r. I mean, this is what we have. Now, the small v is equal to, we had the r to be 4 pi r squared. So 4 pi r squared times a smaller change in r. The smaller change in r, we've been given the change in radius is 0.04. So times by 0. Oh, what is wrong with Maurice's network? 0.04. But let's not forget that the question said that the change in volume, which is the smaller v, is 25 cm cube. So here will be 25 cm is equal to 4 r squared times 0.04. And the question says we should find for the approximate value for the radius. So that means you are looking for this radius. And so we are going to do arithmetic. Arithmetic, what are you going to get? What are you going to get? So r squared will give us r squared will give us 25 divided by, right?
Yes.
25 divided by, why is that distance? 25 divided by, we have 4. Divided by 4 pi, what else? Times 0.04, right? 0.04. So r will be the root of the whole of this. So r is going to be the root of the top one, the above. The root of above. What are you getting? Please do the listen, check. Factor the pi and everything.
I get 7.05.
7.05. Who is this? Who is it?
Yeah.
Mildred.
Uh,
Is it Mildred?
yes.
Okay, good. So 7.05. So that will be our answer. I hope you are clear now. The question gave us the change in volume to be 25. The smaller change in volume, that's it. And the change in radius, the smaller change in radius, there's it. And so ours was just to find for R, given that R, we find that R in this. So there's it. This is what we find. We're just giving the answers. So we just factor it in there. We are just good to go. Let's do some 1B. I'm reading the surface area. Clear mind, dry, it's clear. So, Maureen. Watching. Okay, so the surface area. So you're right. The surface area. The surface area into bracket A. The surface area into bracket A. The surface area of a sphere. Of a sphere of radius R is given by the formula. Is given by the formula. Given by the formula A is equal to 4 pi r squared. 4 pi r squared. 4 pi r squared. When r is equal to r is this in radius. When r is equal to 5 cm, it is increased. It is increased. Sorry, it is decreased instead. It is decreased. It is decreased by 3%. By 3%. Yeah. Decreased by 3%. It is decreased by 3%. Find the approximate percentage. Find the approximate percentage decrease in the surface area. So let's do this one. Let's do it. The surface area A of a sphere of radius r is given by the formula A is equal to 4 pi r squared. When r is equal to 5 cm, it is decreased by 3%. Find the approximate percentage decrease in the surface area. When this thing cuts, you start again and do the final part. Yeah. Your love is kind, your love is patient. Too much.